Hi guys, we're going to have a little work through, hopefully some work that you've done for today about current, charge and energy. Before we do, I just want to have a quick run through some of the new units we might have mentioned here. We're going to talk today about something called charge in an electric circuit, okay? And the unit of electric charge is something called the coulomb. So we measure electric charge in coulombs. You'd measure distance in meters, time in seconds. We measure electric charge in coulombs. We abbreviate that to a letter C. So, for example, 8 coulombs would be 8C. And if we are showing coulombs in an equation, working this out something with coulombs, we use the so I'll just put up here in an equation Q, because that actually stands for quantity of charge. They'd already used C for something else, so we've got Q for coulombs there. Okay, we're also going to talk about potential difference. So potential difference, which we measure in something called volts. Okay, so volts is the measure of potential difference. If we were talking about an amount of volts, say 8 volts, we would use 8V for it. And this is an easy one. In an equation, we use the letter E for potential difference. We're going to talk about current today as well. Okay, the unit of current is actually the ampere, like that, but we quite often actually just put amps for it. Okay, so amps is the common thing to say. It's a short version of ampere, basically. If we were talking about an amount of amperes or amount of amps, we would say 8 amps. And this is a confusing one. In an equation, we actually use the letter I. That's because it was a French person who came up with the idea of current. The unit's named after ampere, and in France they don't call it current, they call it the intensity de courant. Therefore it starts with a letter I, like that. The only other thing I think we're going to talk about today is energy, and this is one that we've come across before anyway, so this is nothing new here. The unit of energy is the joule. We would measure it, say for example 8J for 8 joules, and the letter we give energy in the equation is an E. Okay, so that's an easy one to remember. We might as well say it while we're here as well. We're going to talk about time as well. In physics, we always measure time in seconds, never in minutes, never in hours. So I would say, for example, 8 seconds, and in an equation, we use the letter T for it. So that's something we're going to need to know about today. Different units we use, different letters we use to represent them in equations. So, thinking about our bit of work that we've done today. So first of all, we're going to start off with question number 1, which we did a little bit of reading, and then we have to explain how current flows in a metal. Use the words electron and charge in your answer. So I've got current flows in a metal as the electrons, so I've used the first word they've told me to use there, which have a tiny electric charge, move through the wire due to, and this is something I mentioned yesterday, it doesn't say it in the text, but I mentioned it yesterday in the bit of work we did, it's due to an electromotive force. The power supply of the battery provides an electromotive force, which I don't really like the word, but they do use it a lot in the book. It pushes the electrons through the wire there, and of course the charge that an electron has is, actually I could add that in, couldn't I? I could add in a negative charge there. Okay, so for number 1, current flows in the metal, the electrons have a tiny negative charge and they move through the wire. This bit that I put here, actually, this bit where I put due to an electromotive force, is sort of like extra. Okay, so that's something you would have put on here. Right, number 2, we've been introduced to an equation stage on our bit of reading. We have found out that we can actually use an equation which says charge equals the electric current multiplied by time. Okay, so we're going to use this equation here to work out some stuff in this next question. So the question number 2 says a current of 2 amps flows through a lamp for 8 seconds. Calculate the charge. So we're going to use this equation to calculate the charge if a current of 2 amps flows for 8 seconds. It's a good habit to get into when you're doing this is to write down the equation of your unit first of all. So the first thing I'm going to do for this question, now I'll move it up a little bit, is I'm going to write down the equation I use. I don't have to write the words out, but what I'm going to do is I'm going to write the letters that represent these words down. So you might remember from just now which letter did we use for charge. Let's have a little look. Q for charge. So I'm going to put Q equals current, that we remember we used the letter I for. I times by time, we'll just use a lowercase t at the time there. If it's a capital letter, it's because it's been named after a no, I'm just saying there. Right, next thing we do is going to substitute the values in. So how have I got anywhere I need a current value in my area? Okay, so first of all, do I know a current? Yeah, I've got a current of 2 amps in my thing, so I can substitute that value in. So I can say Q is equal to 2 amps multiplied by, do I know a time? Yes, the time is there. Brilliant. So I can do 2 multiplied by 8. Now, next stage, what I'll do is rearrange my equation to get the thing I want on the right side of the equals. I don't need to do it in this case. It's already there. This is already in the right form, so I can just leave that step out. Do I need to simplify it? Have I done anything that I need to, do my BODMAS on before I move on? No, I don't need to do that either. I can just move straight to the solving stage here. And 2 times 8, I don't need a calculator. I'm allowed to use a calculator in science, but I don't need to for this. I can do that in my head. 2 lots of 8 are 16. And I am working out an amount of charge, so it's measured in coulombs. So I put a, there we go, look, capital C. I've worked out there is a charge of 16 coulombs in that one there. So question number 2, the answer was 16 coulombs. That's how we worked it out. Now, question number 3 down here. Current, read off the book. Current in a lamp is 0.5 amps. Calculate how long it will take for 10 coulombs of charge to flow through the lamp. So basically, I've got 5 amps. How long for a charge of 10 coulombs to flow? So I'm trying to work out now an amount of time in this case. Okay, so I'm going to use this little area again to work it out. What equation am I going to use? The same one. I know I've written it before. I'm going to write it again anyway. So I'm going to use Q equals I multiplied by T. Now I'm going to substitute my values in. So in my question, first of all, I've got a value of current. So I'm going to substitute that one in first. 0.5. How long for a charge of 10 coulombs? So I've got 10 equals 0.5 times by my time multiplied by T. So now I'm on this stage, rearrange. I need to rearrange this to get this on its own. Okay, so how am I going to rearrange this here? Well, I've got 10 equals 0.5 times T. In that case, I'm going to rearrange it to have T equals 10 divided by 0.5. Okay, I've just rearranged that formula. If you haven't done rearranging in maths yet, you will do. Okay, this is just something you're going to have to sort of pick up here. That's how I rearranged that there. What I did was I divided this side by 0.5 to cancel that out. But because I did it to that side, I need to do it to that side as well. So I've got 10 divided by 0.5 to give me my T. Do I need to simplify it? No, it's already as simple as it needs to be. So I don't need to do that. And just to show, I obviously can do this in my head, but just to show you, you are allowed to use a calculator here. All I need to do at this stage is 10 divided by 0.5. The answer is 20. So I've worked out my answer is T equals 20. So down here in my actual where the question was, what I'm going to put the time was 20. It's time, so I measure it in seconds. It's always important to put the unit on there as well in science to make sure we know what we're actually talking about. Next one was number 4. Calculate energy if 8 coulombs of charge flow through a potential difference of 3 volts. This time we're going to use a different equation we've been introduced to. We've got E equals Q multiplied by V. So energy equals charge multiplied by voltage. So we're going to calculate the energy. I'm going to use the same format that I did above there. We're just using a different equation this time. So what I'm going to do is I'm going to do energy equals charge multiplied by potential difference. Looking at my question down here, have I got an amount of charge? Scan through the question. Yes, I've got 8 coulombs there. So back up there in my working out area, my energy, or done in blue now, it doesn't matter. I'll change that consistency. Was 8 coulombs multiplied by. Did they give me an amount of voltage in the question? Bingo bango, there's 3 volts down there. Times 3 basically. Do I need to rearrange it? No. Do I need to simplify it? as simple as can be already. So my energy is actually going to be 3 times 8. Obviously, I can work that out in my head, but this is science, so we're allowed to use a calculator. 3 times 8 is going to be 24. So my energy was 24 down there. Coming up down the bottom, 24. It's energy though. What do we measure it in? We measured it in joules. So the answer is joules. Okay. Number 5 down here. Cup out of the way. 150 joules of energy is transferred by 50 coulombs of charge. Calculate V. Calculate the potential difference on this one here. So I'm using the same equation. Let's lay it out in the same way as we did before. I've got the equation E equals Q times V. Next step, substitute in my values. I've got 150 joules of energy equal to 50 coulombs of charge multiplied by what potential difference. That's what I'm going to try and work out. My next step, rearrange. I need to rearrange this to get the V on its own. So what I'm going to do is I'm going to divide this side by 50, which means I need to divide that side by 50, which means I'm going to get left on its own. V is equal to 150 divided by 50. Okay. Do I need to simplify at this stage? No, it's simple enough. So I'm going to say V equals 150 divided by 50. How many 50s go into 150? There are 3, and it's a potential difference, so I measure it in volts. It's a capital V. It's a person's name, Voltaire. Alessandro Voltaire came up with the idea of potential difference. It's a capital V for that. Okay, so that's another thing. Now we can try our checkpoint questions over here. So moving over to our checkpoint question. I've already set up what I'm going to write. So first of all, the first checkpoint question was the current in the circuit is doubled and it is switched on for 3 times as long. Explain the change in the amount of charge that flows in the circuit. So if I double the current is the amount of, in fact, let's put it up here. If I wanted to work out the current, current is the amount of charge that flows over a certain amount of time. And there's my equation again, that I equals Q divided by T. What's going to happen? If I double the current, that means twice as much charge must have flowed over the same amount of time to give me over a certain time. Double the amount of charge that flows. What about if I left my circuit on for 3 times? So this number was 3 times as big. So if I had the same amount of charge but it's on times as long, see what I'm saying? If I leave it on for 3 times as long as that, then change the amount of charge that's flowing over there. So this amount of charge is flowing, but it's on for longer, which just means 3 times the amount of charge is going to have flown. Okay, if the current is going to be the same, it's going to be 3 times the amount of charge. So the longer I leave it on for, I can just say the more charge flows. Okay, 3 times as much charge is going to flow if I leave it 3 times as long, basically. Strength question number 2 here says, explain what happens to the charge flowing in a circuit when the cell is replaced by a cell with double the potential difference. So each unit of charge will, so here we're using the other equation. Let's remember this one, look. E equals Q times V. Okay, so if I double the potential difference, what is happening what they're saying is explain what happens to the charge flowing in a circuit when the cell is replaced by one with double the potential difference. So if the potential difference is doubled, that means that each unit of charge will transfer double the energy. Okay, if this one here doubles, the amount of energy is going to double up because you're timesing that number by 2. Each one of these is carrying more charge in this case. Okay, that's what's going on there. It's the amount of energy per unit of charge. Right then, extension question. The question says, label on a 12-volt car battery says that it will give a current of 44 amps for 1 hour. Calculate the charge and potential energy store in the battery. So we're trying to work out 2 things here. We're trying to firstly work out a charge, and we're trying to work out an amount of energy. There's 2 things to work out. So what can we do here? I want to work out an amount of charge. I'm trying to find Q is an amount of charge, isn't it? So I need two things to work out Q. I need I and I need T to work out the amount of charge. Of course, I could rearrange this, couldn't I? I could rearrange that equation that I've already written down there to get Q on its own, first of all. So I'm actually going to use Q is this equal to I times T. Have I got current? Have I got time? Let's check out up here. Brilliant. Look, I've got a current in my question, first of all. So my current is, over there, current is, if I substitute my values in, 44 amps. Time is 1 hour. Can I write 1 straight in there? No, I cannot write 1 straight in there because we always need to measure time in seconds. So if I think about this now, what I've actually got is 1 hour. How many minutes in an hour? 60. So I need to do 1 times 60 to start with. So I've got 60 minutes. Okay, but there's 60 seconds in each one of those 60 minutes. And now I need to times that by 60 as well, which means I've actually got 3,600 seconds. Okay, so I've had to convert from hours into seconds to start with. So I've got 3,600 seconds. So now, do I need to simplify? No. Do I need to rearrange? No, don't need to do any of that. I can just work this out straight away. I can work out that. Oh, Daisy, go around. Okay. So I've got 44 amps, 3,600 seconds, which means the amount of charge that flowed there was 158,400, and what we're measuring it in, coulombs. Okay, now, I've worked out the charge. Brilliant. I've done that first part. Now I need to work out the energy. I need two things. Charge and voltage. Let's look at my question. I've got the voltage up there. Have I got charge? Yes. Just work it out down there. So that's good to go. So now all I need to do is the same thing for this. I'll rewrite it over so I've got a bit more room. Energy is equal to, what is my charge? 158,400. I just worked out. What is my voltage? 12. They told me in the question. So now all I need to do is 158,400 times by 12, which says my energy is 1,900,800 joules. Okay, or 1.9008 megajoules. That's what that means there. Okay, last one then is the exam style questions. A phone battery has a potential difference of 4 volts. Explain what this means. Okay, so all I'm going to do is, if you've got to explain some physics, you just got to think about the my dad's on the phone. Phone battery has a potential difference of 4 volts. Explain what this means. So what it means is, if I think about this equation, I can use the energy equals charge times the voltage. And if I'm talking about, what does this mean? What does the potential difference of 4 volts mean? So what I'm going to do is I'm going to rearrange it to get the V on its own. So I'm going to say the V is actually equal to the E divided by the Q. And now I can just put this into words. Okay, I can just put this equation into words. So I can say a potential difference of 4 volts means that there are 4 joules transferred per coulomb of charge. Okay, it's the amount of energy transferred per unit of charge. So that's all you need to do. Anytime in physics to explain what it means, just look at the equation and say, well, it's the amount of energy over the amount of charge. I could even just say that would be fine. I could just say it's the amount of energy over the amount of charge. Would explain that. Okay, obviously when we get back to school, we'll be doing a lot more practical work on this and seeing how these numbers actually relate to the real world. But well done for that. Hopefully you got some marks on that one there. See you again tomorrow.